Good afternoon, everyone, and welcome to part 3 of the course on designing pedestrian facilities for accessibility. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation in this training. Please note that part 4 of this webinar series will be on Thursday afternoon. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. And if you could please go ahead and type in your initials and send those to us as an informal roll call for today's session. And I see those arriving already, so thank you for that. Throughout the course presentation, please use the questions box to send in any questions you might have, and I'll be dispatching those periodically to the instructor for comment. Please note also that the handout section of your GoToWebinar panel includes several PDF resources that we'll be referring to during this course. With that, we will go ahead and turn things over to our instructor, Ron Eck, with the West Virginia LTAP Center. So welcome, Ron.
Thank you, Mike. Welcome, everyone. Welcome back, or welcome if this is your first session. This is part 3 or day 3 of designing pedestrian facilities for accessibility. And just to refresh everyone's memory, since we had a weekend since our last session, on day 1, we did some background laws and regulations and pedestrian characteristics. We started into the pedestrian access route and the requirements thereof. We continued that. On the second day, we talked about curb ramps. Today, we're going to continue our discussion of curb ramps and other transitions, and also talk about detectable warning surfaces. And then Thursday, we will talk about crosswalks, accessible pedestrian signals, and street furniture and on-street parking. If you have any questions about day 1 and day 2, or questions that arose out of those days, feel free to put those in the chat box and Mike will relay those to me. But I don't believe we've talked about curb ramp width yet. The PROAG minimum, of course, would be 4 feet. That's the minimum width of the clear unobstructed path. But my feeling is that the wider ramps are better, and the curb ramp should be the full crosswalk or sidewalk width. Just as an example, here where I am in Morgantown, West Virginia, we're fortunate we had a lot of railroad lines decades ago that served the coal mines in this area. Of course, the mines are worked out and the railroads have left, but those former rail lines are now a nice system of multi-use trails, shared use paths throughout our region here. And oftentimes, of course, and those paths are hard surface, usually asphalt, 10 feet wide, accommodate bikes and pedestrians. Where those paths or trails cross a roadway, we of course need a curb ramp and detectable warnings. And those curb ramps, where those trails cross a public road or street, are the width of the trail, 10 feet wide. So like I say, the best practice is to make them the full width of the crosswalk or the sidewalk. I think last week I mentioned from time to time the turning space. This is the level area at the top of the ramp where people in wheelchairs or those using walkers or braces can make their turn. And remember, when I say level in this class, I mean 2% cross slope or flatter. The criteria you can see on this slide, the minimum of 4 foot by 4 foot turning space. But I should note that that dimension, that minimum, applies for what's called an unconstrained condition. And look at the ramp that's here. Get my pointer. We have a curb ramp and then we have a turning space at the top. And notice adjacent to the turning space at the back of the sidewalk is basically grass. That grass is essentially flush with the sidewalk, more or less. That would be called an unconstrained condition. Someone in a wheelchair, manual chair, coming up the ramp, their footrests can act, the footrest on that chair can actually go out over the grass. So they could turn in a 4-foot by 4-foot turning space. So this is an example of an unconstrained condition, and that turning space could be 4 by 4. But notice if there's a constrained condition, for example, let's say there's a curb here, and maybe behind the curb is that curb forms a bed of flowers or something like that, or some landscaping behind there. That would be a constrained condition, or maybe there's the storefront there, the wall of a building. In that case, the turning space must be a minimum of 5 feet in the direction of travel. So those are essentially the two conditions. For unconstrained, they can be 4 feet in the direction of travel. In a constrained condition, the minimum is 5 feet in the direction of travel. And that's what we're trying to show here. You can see that would be the minimum 4 foot by 4 foot. But if there's, let's say up here is a storefront of some shops or something like that, or a curb or a wall, then that turning space needs to be 5 feet in the direction of travel. And notice this turning space can be a rectangle. If the ramp is 4 feet wide and this is 5 feet, we can have a rectangular turning space. Desirably, it'd be nice if it was 5 by 5, but it can be 5 by 4. Here's a turning space example. Notice that this turning space serves both ramps, and that is acceptable to do that. That's what we're trying to show. I would point out this is not the best example. Perhaps notice the ramps lack detectable warning surfaces, which they need. That's required. And also, I don't know the numbers here, but I'm not sure about the ramp may be too steep. This looks like maybe an 8-inch high curb to me, and this looks like just a couple, 2.5, 3 feet maybe. So I think that ramp may be too steep. But anyway, be that as it may, what we're trying to show here is the turning space that serves both ramps. Without a turning space, of course, users, whether they're in a wheelchair or using a walker or crutches, have to turn while they're climbing. And I think you saw in the videos last week that is extremely difficult, and not everybody has the upper body strength to do it. So for every ramp needs a level turning space at the top. This static photo does not do anywhere near justice to the difficulty of making that maneuver. I remember in the Train the Trainer I told you about on the first day, I think the first time I tried to do something like that, I ended up rolling back right out into the street. It is a very difficult and challenging sort of maneuver. So it shows the importance of having a level turning space at the top of each ramp. And of course, without a turning space, another issue is that pedestrians who are just continuing around the corner, not crossing the street, they have to go over the flares and the cross slope of the ramp, the 8.3% cross slope of the ramp, which is not a good situation. And like in all of this work, the details are really critical. Details, details, details. Notice this ramp and turning space look relatively new, but with the fire hydrant right here, it's essentially a non-functional turning space. So those details are critical. And if we look down here in the lower right, notice at the back of that turning space, it looks like some sort of a retaining wall or curb. That's a good example of a constrained condition. So this, it looks like it is pretty adequate here, but this would need to be a minimum of 5 feet in the direction of travel. And it appears to be, other than the darn hydrant there. Another thing to keep in mind is that PROAG says the bottom of the ramp must have a 48-inch by 48-inch clear space entirely outside the parallel vehicle travel lane and within the crosswalk. And notice this single diagonal ramp does not provide that. And notice, I want to emphasize, this is just space. It does not have to be level. There just has to be clear space outside the vehicle travel lane and within the crosswalk. And just, I see sometimes agencies may paint, connect the crosswalks here with some marking material, but that that still doesn't make it within the crosswalk. It really needs to be within the crosswalk, this crosswalk or this crosswalk. We talked last time about the flared sides. If the curb ramp is in a pedestrian circulation area, and if you recall, these flares are not part of the pedestrian access route, the criteria are that that flare is 10% maximum measured parallel to the curb. So it's 10% maximum slope measured parallel to the curb. And that, some might say, well, if it's not part of the pedestrian access route, why is that really an issue? Well, it's an issue because these flares are here for the safety of able-bodied pedestrians. And if those flares are too steep, there's a good possibility of an able-bodied pedestrian tripping and falling, or when those get snow-covered in northern climates, obviously a steeply sloped flare like that covered with ice or snow can be extremely dangerous. So the reason for that flare requirement is not so much accessibility, it's really for the safety of able-bodied users. Where we don't have a pedestrian circulation area across the ramp, like here we have the grass strip or tree lawn here, then we can use vertical curb returns like you see here. Another example, not the best example, it lacks detectable warnings, which need to be here, but notice rather wide grass strip here. Not a pedestrian circulation area, so we can use the vertical curb returns. And just to show you how different users have different perspectives or use of these facilities, would you agree that a blind pedestrian would probably prefer the vertical curb return to the flared sides because they can detect those? This is a detectable edge here on both sides of the ramp. On the other hand, if someone's in a wheelchair and their wheel gets up on the top of the curb, there is a danger of perhaps the chair tipping over. So there's pluses and minuses for different, depending on the category of user. One other aspect I've heard, and I agree with it, associated with the vertical curb returns is that there is kind of a shy distance associated with these curbs, meaning pedestrians, at least sighted or those in a wheelchair, will tend to shy away from the curb. And so that reduces the functional width of the curb ramp. So that's something to keep in mind when you're designing the ramps if you're using the vertical curb returns. Another key issue with curb ramps is drainage. Before the pandemic, when I'd travel around the country doing in-person training, it's probably fair to say in most communities I visited, I would see something like this: water at the base of the ramp, or in the wintertime in northern climates, that freezes, turns to ice. So then it's more than a nuisance, it can actually be a safety issue. So we do need to pay attention to drainage. Of course, the textbook solution would be to place inlets upstream of the ramps. Of course, in reality, we can't always do that, but we should pay attention to drainage to make sure we don't get standing water at the base of the ramp. And of course, here we're trying to show putting inlets upstream of the ramps where possible. Ramp surfaces. Surfaces of ramps should be smooth. Texture makes them hard to climb. It's too bad we can't do a field activity to demonstrate that, but if you ever get a chance to get in a manual wheelchair, try to go up a paver block or brick surface ramp and then go up a smooth concrete ramp, and you'll see that it's harder to climb a textured ramp versus a smooth ramp. So ProAg would allow both of these surfaces. I don't know if ProAg would allow this ramp. It looks like the flare is kind of steep here, and I'm not sure there's much of a landing there. But assuming this was compliant in other aspects, PROAG does not prohibit a paver block or brick ramp. I personally don't recommend them. I recommend, as I think I did last time, just for walkways in general or travel ways, they should be smooth surface, especially the turning space. It's also harder to turn, whether it's a wheelchair or a walker or crutches, harder to turn on a textured surface than a smooth surface. There are 3 types of sidewalk to street connections, and that's what I'd like to spend some time looking at now. There's 2 types of curb ramps, the perpendicular ramp and the parallel ramp, and then there's something called a blended transition. And if you're not familiar with that, don't worry, we will talk about what a blended transition is when we get to that point. But notice the curb ramps have a running slope between 5 and 8.3%. With a blended transition, the maximum running slope or grade is 5%. We'll start by looking at perpendicular curb ramps. Notice with perpendicular ramps, there's 2 ramps per corner. So there's a ramp for each crosswalk at this corner. Notice there should be a level turning space at the top. And if the ramp is in a pedestrian circulation area, sidewalk like this one appears to be, we need to have the flared sides. And of course, the turning space dimensions depend on sort of what's at the back of the sidewalk. If this is grass back here, we can use a 4x4 foot turning space. If this is a storefront or a curb or some other obstruction or constraint like that, then it needs to be a minimum of 5 feet in the direction of travel. Curb ramps need to be perpendicular to the curb so that both wheels of the wheelchair enter and leave the ramp at the same time. That's particularly important. Hopefully nobody has one of these, I call them skewed ramps. I do see them from time to time, but these are not good. Notice this is the cartoon depiction. Down here is kind of a simulation of that. Notice in that, because of that skewed ramp, that one wheel, this wheel right here, is off the ground. And recall we said, and you saw in the video last week, anytime one or more wheels of a manual chair is off the ground, the stability of that wheelchair is jeopardized. So we want to make sure that our designs are such that all 4 wheels of the manual chair stay on the ground at all times. Here are the requirements for perpendicular curb ramp cross slope. So here we're talking about the slope in this direction at right angles to the direction of travel up and down the ramp, which also relates to the cross slope of the crosswalk crossing the street. And before I get into this, I should note that these requirements apply to new construction. These are for new construction. But notice I have 2 sets of values here. One is what's currently published in PROAG, and the other is what is expected to be in the final version of PROAG, which is slightly different. Now, I would have you notice that the cross slope requirements depend on the traffic control on the roadway being crossed here. So currently, if that roadway is stop or yield controlled, the maximum cross slope is 2%. If that roadway is signalized or uncontrolled, like meaning the through roadway at a 2-way stop, for example, that would be uncontrolled, or a mid-block crossing, then the cross slope can match the street grade. But the expected revision is that for stop or yield control, it would still be 2% max, but for a signalized intersection or uncontrolled approach, the max cross slope would be 5%, and for a mid-block crossing, the cross slope can match the street grade. So think about it, this may affect how we design intersections. We probably want to table them so we have a gentle grade in the vicinity of the crosswalks so we can comply with these cross slope requirements. But again, these would be for new construction. Here's an example of a perpendicular curb ramp for discussion probably. You can see the common turning space here. And then we have this ramp and this ramp. One thing I don't like is the fact that they are brick surfaced. If you recall, I said texture makes them harder to climb. Personally, I'd probably want to make this smooth concrete here and here, and maybe put if you want the color and the texture of the brick, this is just my thoughts, maybe put that here. This is hard surface, it's level. I guess pedestrians could stand there or walk there, but to me that's not really a significant pedestrian sort of circulation area there. What else can we say? Notice here, I guess they are considering this a circulation area because they use the flare sides here. And on this side and on this side, because we have the grass strip here, this is not a pedestrian circulation area, so they use the vertical curb returns. But I do like that the turning space is smooth concrete. Summing up perpendicular curb ramps, these are probably the least likely of the designs to pond and trap sediment, so that's a good thing. Also, the user has some setback from traffic while they're waiting to cross the street. There's two main disadvantages, though. One is that it's difficult to provide a good path of travel on large radius corners. I think we saw that last week. And also, as we talked about when we discussed how to determine ramp length, we saw that they can require a lot of space, maybe 8 foot for the ramp plus 4 or 5 feet for the turning space. So you may be talking 12 or 13 feet. So you may need to look at something like a curb extension or wider sidewalk to accommodate the curb ramp and the landing.
Hey, Ron?
Yes, sir.
Oh, sorry. We have a question from Sam who said, referring to the previous slide or photos, do those brick curb ramps comply with the color contrast requirement between the truncated domes and the rest of the ramp?
Good question. And we will talk about this in more detail here in a few minutes. But just to answer the question, I would say yes, they do. I think there's probably enough contrast there. What would we call this? Call it sort of a cream color maybe, or a pink, and this is kind of a darker brick red. So personally, I think that has enough contrast there. I may show you some examples here, if not today, next time, where the agency used two different tones or shades of red that personally I'm not sure they provide enough contrast, but these do. And just a note, we'll get into this in more detail, but the original version of PROAG said that there needed to be 70% contrast between the detectable warning surface and the background and the sidewalk. There was considerable, I guess, confusion of how do you calculate that 70%. So the current version of PROAG, the 2011 version, just says there must be visual contrast between the two surfaces. So they leave it subjective compared to the original version of PROAG. So the second type of curb ramp, which is intended to address that, the width of sidewalk needed to put in a perpendicular ramp, is the parallel curb ramp. And notice here, the sidewalk ramps down and the turning space is essentially at street level, and actually the detectable warning surface is part of the turning space. So this is a parallel ramp. Notice the slide says a minimum of 4 foot by 4 foot turning space at the bottom of the ramp. That is true generally, but notice in this case, at the back of the sidewalk here is a curb or retaining wall, and so that creates a constrained condition. And so in this case, the 4 by 4 turning space is not applicable. That's the 4x4 is for unconstrained condition. So here we would need 5 feet from the back of curb to the face of this curb or retaining wall. Hope everybody's clear on that. And the detectable warning is part of that turning space. Some people ask, do we measure from the detectable warning here to the curb? No, we measure from the back of curb to the face of this retaining wall. So in this case, and I'm not sure that is 4 or 5 feet, it looks more like 4. This looks like a 4x4 turning space. But really, this needs to be 5 feet from the back of curb to the face of that little wall. And there's just another perspective on that. That curb is not required, but it may be needed, to prevent sort of sloughing of material onto the sidewalk and onto that turning space, which then creates its own issues for sidewalk users. And these are the cross slope requirements for parallel curb ramps and for the corresponding crosswalk. These are identical to the ones I shared with you a few minutes ago, so unless someone has questions, I'm not going to repeat that again, other than to note again that these are for new construction. The advantages, or the main advantage of parallel curb ramps, is that they fit within the narrow right-of-way, as you saw. Disadvantages are that the users who are continuing along the sidewalk, who are not crossing the street, have to negotiate ramp grades. And to me, maybe the biggest disadvantage is that we do have to give attention to the construction of that bottom turning space to limit the accumulation of water and debris or sediment in that turning space. I know in my travels in the past in some of the northern states, and I'm not trying to pick on them, but because it happens, but those that, especially northern states dealing with snow removal and ice control, sometimes in the spring you'll see that turning space is really completely filled up with anti-skid material and sediment to the point where you can't even see what color the detectable warning surface is because it's covered under a sort of a layer of sediment. And obviously then that's a maintenance effort for the road agency to clean that all out in the springtime. So that's an example of what I'm talking about. But again, in some cases, the best design is the parallel curb ramp, but we need to be aware of these disadvantages. So those are the two types of curb ramps. The third type of sidewalk to street transition is the blended transition, which you see in the photo here. Notice the curb is missing around this entire corner. This is a blended transition, and because the curb is missing, we need to use detectable warning surfaces here. Recall my rule of thumb, everywhere the curb is missing at a street crossing, we need detectable warnings. But notice a couple other things too. Notice that the maximum grade of a blended transition is 5%. And notice that we don't need a turning space. A turning space is not required at the top of a blended transition. So they are somewhat different from the two curb ramps we just talked about. Here's another example of a blended transition. I'm not sure where this is, but this is, I think this is sort of a government plaza, courthouse and other sorts of government buildings. So it's a plaza, brick plaza, and it is at the same elevation as the street. So it's possible that a blind or visually impaired pedestrian could go into the street without realizing it because there's no curb. So what the agency has done is put in detectable warning surfaces in addition to, so it looks like some concrete and steel bollards, because one of the issues with blended transitions is that drivers may mistake that area for where the curb is missing for a driveway or for a roadway intersection and may actually turn onto the sidewalk. And so these are here to keep vehicles off the sidewalk. And I suspect probably since this, I mentioned this is probably a courthouse or federal building, these are probably also here for security reasons as well. But a key reason, security aside, is just to keep vehicles off of the roadway or off of the sidewalk. And you might be able to see that here. I think you can kind of see so much curb is missing that maybe at night or something, a driver may turn onto the sidewalk. And obviously that's an issue, safety issue for all pedestrians on the sidewalk. And here's a sketch that sort of illustrates that here in the lower left. This is kind of what we just saw. This like a plaza here. This is at the same elevation as the street. It looks like the plaza is brick, the street is brick. This is just a color, like a gray or concrete color. There's no elevation difference there. So the blind pedestrian can inadvertently enter the street because there's no queue there, like in the form of a curb. So this design, I think, improves on that. Notice they've put some ground-mounted planters here to sort of channel pedestrians to the apex of the corner. And then there's detectable warning surfaces here, so that can be detected with the cane or underfoot to alert the visually impaired that they're about to enter the street. But notice, even having said that, notice there's still a bollard here intending to prevent motor vehicles from driving into that pedestrian area. But as many of you are probably aware, these bollards are a real fixed object hazard for bicycles. And many bicyclists are injured in the United States each year running into or catching a pedal on a bollard. So again, it's a matter of trying to balance all users and try to have a, an efficient and safe and accessible setting for all users. Notice in my discussion of these three types of sidewalk to street transitions, I have not mentioned the single or the diagonal curb ramp. And the reason I haven't is highlighted there in red, that these are unacceptable in new construction. So we should not be building any new single diagonal ramps. They may be acceptable in alterations if it's technically infeasible to build one of the other three types of sidewalk to street connections. And the principal reason is, you can see here, is that the curb ramp must land within the crosswalk it serves. And notice this one does not. And again, I'd mentioned just by placing or installing these lines here, pavement markings, does not mean that this ramp lands in the crosswalk. It would need to be over here or over here to land in the crosswalk. Plus, also think about if a blind pedestrian got lined up with the ramp, where would they, once they enter the street, they'd be crossing diagonally, which is certainly not desirable unless there's an exclusive pedestrian phase. But we don't want the blind pedestrians to be, or any pedestrian to be entering the intersection diagonally like that under normal conditions. Also, the diagonal ramp forces the wheelchair users out of the crosswalk. And I think you saw this in the video last week. This individual has come from the top of the slide toward the bottom in the crosswalk. They're headed for this ramp, which is a single diagonal ramp. And notice, to get lined up with the ramp, they have to leave the protection of the crosswalk, and their back is to traffic, which can be very disconcerting. This is what I'd call combination ramp or ramps. Notice we ramp the sidewalk down to a level turning space here, and then the sidewalk ramps down here to continue the sidewalk. And then the turning space also serves this curb ramp. And here on the right, same thing, the sidewalk ramps down to the level turning space, and then we have the curb ramp. Notice this one in the lower right. This looks like it's the desert Southwest, so they don't have grass lawns like we do in the East. It's what, cactus or boulders or that sort of thing. So this is not a pedestrian circulation area, so they used a vertical curb return. On this side, This obviously is a pedestrian circulation area. It's a widish type sidewalk there. So they need a flare. This flare looks to me just visually to be steeper than 10%. And if we look closely, it looks like there's a utility cover here. So that may have restricted their ability to flatten out that flare. So hopefully there's a technical feasibility justification or an exception documented somewhere in the files explaining why this had to be steeper than 10%. But it looks to me still to be accessible to the maximum extent feasible.
Hey, Ron,
Yes, sir.
we have a question from Jamie. What is the allowable offset for pedestrian ramps from one side of street to the other?
Excellent question. I don't think there is a specific number or value that's given in PROAG. That's one of the gray areas. But you'd want to be sensitive to, can the visually impaired sort of find their way? And it would, maybe if it's a signalized intersection where you have APS and you have the locator tones on each corner, that would help guide the visually impaired pedestrian. But if it's, say, a stop controlled intersection or a signalized without APS, then it becomes problematic for them to find their way, because even though you may stripe it with paint or thermoplastic to mark the crosswalk, those markings are not detectable by the cane. So the visually impaired pedestrian doesn't have the benefit of those markings like a normal sighted pedestrian would. So that's something to keep in mind, is what sort of guidance are you giving the visually impaired pedestrian to cross that roadway? Good question, though. So let's look at, I think I have a couple examples, maybe 3 examples here of some curb ramp situations, and I'll share with you my thoughts, but I welcome your input or comments or questions on this, because again, there's kind of no right answer or correct answer in many of these. It's just sort of which is best for the particular situation, and obviously each situation differs. But I think we'd all agree this is not a good situation, right? Hopefully we don't have many of these corners left in the United States after 30 years of ADA, or after 40 some years since the Rehab Act of 1973. But obviously there's no curb ramps here. And let's imagine this municipality is going to resurface this street here on the right side of the image. And they realize under Kinney versus Jerusalem, court decision that we talked about last week, that as part of that resurfacing project, they need to bring the curb ramps into compliance with the current criteria. So this is what they plan to do. And this is photoshopped in there. I realize it looks a little weird, but let's assume some values, and some of them are marked. Notice the sidewalk is 5 feet wide, so that's a good thing. So the sidewalk here is 5 feet. So we ramp, this is a kind of a combination ramp. We ramp the sidewalk down to a level turning space, 5 by 5, which serves both ramps. We do the same thing here. And then we have our ramps, and I realize these look kind of steep, but let's assume they're 8.3% and 5 feet wide. So let's assume they're PROAG compliant. I think that looks okay. Notice this area here, the buffer zone on both sides, is not intended for pedestrians, so you can use the vertical curb return sides. This is hard surface, but I would contend that's not really a pedestrian circulation area. It's kind of hard for a person on foot to move around there. So I think it's appropriate to use the vertical curb return here. Notice a little retaining wall here. I'd say that depends on your specific conditions. I mean, if you could grade that and then, get some grass or some turf or something established there to kind of prevent erosion or slipping of that slope, you might be able to get by without that that little wall there. But on the other hand, maybe you do. So they're showing having a little retaining wall there. But to me, that the answer to that would be it depends on your specific conditions there. You know, the height of that excavation, the type of soil you're dealing with, and that sort of thing. So that's example 1. Here's example 2, which is a different community, a different intersection. Notice they have a single diagonal ramp at 9%. Also, if you look closely over here on the left side of the image, notice getting to be some alligator cracking, maybe some pothole formation here. So let's assume this agency is going to resurface this roadway. It's reaching the end of its useful life. So they're going to resurface this roadway. And again, they realize that they need to bring the curb ramps into compliance at each of the corners. Notice a single diagonal ramp is not compliant. And so they're going to need to put in maybe a perpendicular ramp, or 2 ramps, I should say, at that corner. So they assign this to one of their staff members to come up with a design, and this is what is presented to them for review. And notice mainly, this is just a blunder here. We wouldn't have this signal pole in the middle of the sidewalk. You can assume that signal pole is in the grass here. But notice this is the same thing. We're ramping down the sidewalk here to a turning space, doing the same thing back here. And then we have our curb ramps, and the sidewalk wraps around here. And this is all grass, so that is detectable. So a blind individual who wasn't crossing the street here could go around the corner. They could find their way and realize that at least here, the sidewalk doesn't go to the street. The street crossing would be at this point. Again, notice they have a little retaining wall. I would call that optional depending on your site-specific conditions. My thought is that this complies with PROAG. But as a traffic engineer, I have some concerns about other issues. And I'm just sharing with you my thoughts. If you all have thoughts, please feel free to share them in the chat box. But notice here, the stop line for this location will be way back here. And similarly over here on the left, we can't see it, but the stop line will be well back from the intersection. Also notice, I don't think they're turning, but if this SUV is turning here, I'm not sure the driver of that SUV is expecting pedestrians to cross way back here. In fact, if there's a pedestrian standing here waiting to turn or waiting to cross, I'm not sure the driver could easily see them because of the pole and the tree and so forth. Also, and maybe it's because I'm from a university city, maybe I see this more than others, but because we have some intersections like this in Morgantown, but with our younger, we have like 25,000 university students here, so we have a younger population. We have some intersections like this, and what they will do is they'll cut across the grass here. They don't want to go out of direction to go down to the crosswalk. They will just cross the road as the extension of the sidewalk. So my point is, this satisfies PROAG, but it may cause or create other issues that maybe relate to safety or other things. So there may be maybe another solution that we might consider. And so in this case, that's what the decision makers did. They said, this works. They said to the designer, but maybe can you give us another option that addresses some of those concerns? So this is the design that was presented then in the second option. And notice, again, we lower the sidewalk to this shared turning space. And we have a curb ramp here and here. Notice again, they're showing a little retaining wall. I would say that depends on your local site conditions. Notice this pie-shaped area. This has a variable height curb here. And that curb height is detectable, should be detectable, so we shouldn't have an issue with a blind pedestrian using the cane walking into the street. And note, and you see it's kind of a ridge here. See, there's the top of the ridge. I think that should work. Notice there's no out of direction travel for pedestrians. The stop line at the intersection can be at the more conventional location. And so I think overall, to me, that's preferable to the previous design. Although notice, to show again how it's context sensitive, notice this curb here. If I were to present that to in the northern states, and if I had snow plow operators in the class, they would probably point that out as something that's going to catch the plow blade. And so you might want to think about something, maybe ramping the curb here to make that more snow plow friendly. Any questions or comments or concerns on any of that material, curb ramps?
Well, Ron, at the moment, we don't have any pending questions, but we just want to remind everybody that the questions box is available, so please type in any of those items at any time.
Yes, please. Well, then we'll continue on. And at this point, I think I'll show the third video in our 4-part video series of the access board videos. This will illustrate some of the challenges faced by persons with low vision. And I think they do a pretty good job of presenting that. You'll see Marcia Maz, who I believe she's now retired from the access board, but she narrates it, and she does have low vision, and so she will illustrate some of her personal examples and challenges of trying to negotiate the Washington, D.C. metro area. The one thing I would note, and I don't mean this as a criticism of the video, because I think the video does a good job of showing low vision issues, but low vision can occur in a variety of forms. What they mostly show in this video, I think, is sort of, what would you call it? Poor visual acuity, sort of very fuzzy type vision, not good clarity. But low vision could also be, for example, tunnel vision, or various types of macular degeneration, which relate to low vision. One type I'm aware of, I forget the medical name, but if you can picture someone who has sort of normal field of view and normal vision, but right in the center of their field of view, maybe almost from top to bottom vertically, is like a big black sphere that sort of blocks the central part of your vision. That is also considered low vision. Also diabetic retinopathy, which unfortunately is a relatively common vision issue that's associated with diabetes. That causes a reduction in visual acuity, but also you may have these black and red large size floaters that kind of float throughout the person's vision that can be very distracting. So I guess the point I want to make is this is a good video, but it doesn't illustrate nearly all the different types of variety of low vision. So let's get.
Hey, Ron.
Yes, sir.
Do we have a moment for a question or
Sure,
two?
absolutely.
All right, first question from Roger. Are diagonal ramps completely forbidden, even in retrofit situations?
Great question, Roger. I would say no, that they're discouraged, but probably the only time I would use them in a retrofit is if it's technically infeasible to use one of the other 3 types of sidewalk to street connections, meaning you can't really use a perpendicular ramp or parallel ramp or blended transition. And if you use it, I'd want to, if you're claiming that technical infeasibility, I'd want to make sure you have that well documented in case there'd ever be a suit or a claim arising over that. A good question.
All right, next question from Brian. Once the ramps are installed correctly, it seems like we have water building up at the bottom of the ramp. Do you have any possible solutions for this that might help moving the water off the ramp?
Oh, you might look, and you obviously have to look at an area broader than just the ramp itself, but you might look at and I don't think I have any images in this presentation that show that, but sort of raising the gutter elevation at the ramp. And obviously you have to work back from that. Otherwise you'll create other low spots. But that would be one thing to consider, is kind of raising the gutter elevation at the ramp and in the vicinity. And if you, like I say, I don't have that image here in this presentation, but if you'd want to email me, I think I could find, with that request, I think I can find an image or two that I have in my library that show how another municipality has handled that by doing that sort of raising of the gutter in the vicinity of the ramp. But yeah, that's a common issue, a common problem.
So Ron, in the handout section, I think those PDF handouts have your email address.
That's correct.
Yep.
That's
Okay,
correct.
thank you.
Yeah, in fact, I think the title slide of each day, days 1, 2, and 3, have my email addresses on those title or cover slides.
All right, thanks.
Yeah, good question. So let's go to the video here.
Ron, I don't see the video playing.
Huh, I wonder what was going on. Let me try again.
Okay.
Do you see it now?
It's starting. I think it's playing. Okay.
Okay, are we back at the slides now?
Yeah, thanks, Ron. And I'm sorry for the confusion. For some reason on my screen, the video was frozen, but apparently for everybody else, the video showed. So,
Oh, good. Yeah, it was showing on mine, so good. Yeah, we apologize for the glitch there at the beginning. And sorry I cut that off, but as I said last week, these videos, I think they're great, but they're a little bit dated. She was going on to discuss the development of PROAG, which obviously is available in draft form now, so I didn't think we needed to hear that. But hope you found that beneficial. Uh, I think it does a good job of explaining the challenges faced by low vision pedestrians. So now, in the remaining time we have today, I'd like to talk about the detectable warning surfaces or detectable warning system, the truncated domes. And here you see an image of them. We've been talking about them. It's literally truncated domes or cut off domes that are spaced some distance apart. This is a researched, scientifically developed surface. It's not just some random surface that appeared. It's designed to be detected by the tip of a cane, by the vision, those who are blind. It's also designed to be detected underfoot by a low vision pedestrian who does not use a cane. And also because low vision pedestrians can't see detail and rely on color contrast, notice the color it doesn't have to be yellow, but the color needs to contrast with the background, the sidewalk itself. So let me get my pointer here, a different pointer this time. Again, I'll repeat, these are used anywhere the curb is missing at a street crossing. I guess doing that didn't work too well. There we go. Sorry about that. Let me get my other pointer back. Okay. The thing I want to mention about detectable warnings, or if I did mention it, want to emphasize it again, is that these devices do not provide any directionality or wayfinding information. There is kind of an urban myth out there about that, but they don't provide directionality. They are strictly a warning mechanism. When blind or low vision pedestrians, before they actually go out and navigate on our streets and sidewalks, they go to what's called orientation and mobility school, or O&M training. And they are taught that when they detect this surface, either with the cane or underfoot, that they are to stop and check out their surroundings. So it's a warning mechanism. And the way the visually impaired would check out their surroundings is principally through hearing, through the audible sounds. They would listen, for example, if there was APS signals, locator tones, or walk indications, or if not, they listen for the sounds of moving traffic to know when it is safe to cross the roadway. So notice here where my cursor is, the curb is missing here. And so where that curb is missing, we need the detectable warning surface. Some of you may have these raised crosswalks or speed tables with crosswalks on them. The street elevation at that location is the same as the sidewalk. And so the curb is missing at that location for pedestrians. So notice on each end of this crosswalk, we have a detectable warning surface. This is on the campus at West Virginia University. I don't mean to pick on them, but it's a good example of what not to do or how little knowledge can be a dangerous thing. Notice, I think whoever, and I don't know who did this project, whether it was in-house or an outside entity, but notice the detectable warning surfaces kind of line up with the crosswalks, but from what, maybe here over to here, the curb is missing and there's not necessarily a detectable warning surface. It'd be possible for a blind individual to walk right out into the street here without realizing it, or the same thing over here. So really what should be done is everywhere the curb is missing. So from the back of curb here, kind of radially around there, there should be a detectable warning system. This is not adequate and it really could be dangerous in terms of safety for the visually impaired. Here you can see the detectable warning surface. PROAG currently says there shall be at least 24 inches of detectable warning surface at the back of the curb. And I'm an engineer. I think I mentioned that in my introduction. And I remember in engineering school, my professors drilled into us, don't design for the minimum, design for more than minimum, for the safety and the benefit and the comfort of the user, whoever the user is. And so an engineer might look at that or hear that and say, well, if 24 inches is the minimum, maybe I should use more than 24. And notice that's what happened here. In fact, here, notice the whole curb ramp is detectable warning surfaces. My personal recommendation is to use 24 inches for a number of reasons. Number one, this material can be expensive, right? So why use more of it than is needed? A second reason, I think I talked last time about how a rough surface can cause vibrations. And for people with certain types of spinal cord injuries in wheelchairs, that vibration can cause excruciating pain. So why cause more pain for a wheelchair user than is really needed? And another reason, maybe this is not the best image to show it, but as some of you probably are aware, some of these materials, and all the materials are not alike, but some of them are relatively shiny, some of the sort of composite or fiberglass type materials. And when they're wet, they can become extremely slippery. In fact, there's legal cases going on right now around the country where able-bodied pedestrians have become quadriplegic because they slipped and fell on a wet detectable warning surface on a ramp, on a slope. And so again, why would you want to use more of a potentially hazardous surface than you need? So my advice is use 24 inches. In fact, I've been unofficially told that the access board is aware of that and that the final version of PROAG will probably say use 24 inches, not at least 24, because that implies kind of it's better to use more than 24 when I've tried to explain that really it's not. I think we've talked about most of this. There are a variety of different products. Just here are some. This is sort of that composite material fiberglass I mentioned. This is cast iron. It's made by the same foundries that make the grates and manhole covers and things we deal with in public works. This is popular, I've seen across the northern tier of states in the US in snow country, because this is very rugged and durable, withstands snowplow blades and snow shovels and rotary brooms and de-icing chemicals and all that sort of winter related things that create challenges for us in public works. This is the brick or block type. I think I showed you an example of this before. I have to admit, I'm not a big fan of these, but depending on your climate or situation, they may work or be appropriate. And these are just a sampling. There's certainly other products available as well. I did want to say, though, I don't recommend this at all. And this I mainly see in smaller towns and communities who think they have a low-cost way of creating the detectable warnings. You can purchase mats, rubber mats that have the domes in them, and then you place that over the fresh concrete. And after the concrete's cured, you remove the mats. But notice one of the big issues is very poor quality control. Notice there's whole sections here where there's literally no domes. The other thing is, unless you color your concrete, to get the color contrast requirement, you're going to have to paint this. So you're painting a surface that's on a slope, and when that gets wet, that can be extremely slippery. So it can create safety issues. And also, again, relating to kind of the northern climates, you think about it, if you do this, say in the fall, in September or something, you're going to have kind of green concrete like this next to the roadway. And when you start applying, or when the agency starts applying your chloride de-icing chemicals, they will very quickly deteriorate those domes. So I've seen some communities by spring, the domes were completely gone, spalled off. So I would recommend not using this. There is a requirement for visual contrast. I think I mentioned that earlier. And notice yellow on concrete. Some people have told me they didn't think that was sufficient visual contrast, but I think it is. The Access Board would agree. In fact, some agencies have said that yellow is the only color that can be used in that jurisdiction. But mostly, I think most agencies, at least now, do give designers the ability to use a variety of colors. But here, notice, in fact, it's hard to see because we have a gray detectable warning surface on gray concrete, and that is simply not adequate contrast. In fact, we can't even see the detectable warnings in the slide. I know a number of agencies use black, and black obviously provides good contrast on light concrete, but this is one of the things we've kind of learned through experience that maybe no one appreciated at the outset, and that is that service animals, guide dogs, and individuals with certain low vision conditions perceive this as a hole in the sidewalk. And so if it's a blind individual with their guide dog, the guide dog will sort of lead them around that what they think is a hole, and that may create other issues. So the current recommendation of people in this area is that use any color that provides good contrast, but not black. In fact, I wouldn't be surprised if when the final version of ProAg comes out, it says essentially the same thing. Use any color, but avoid using black. And here are some examples of visual contrast. Up here, that's good. Obviously, this is not good. It looks like white on light gray concrete. That would be difficult, if not impossible, for a low vision pedestrian like Marcia in the video to detect those domes without stepping on them. I think the bare metal, once it starts to weather on concrete, that provides good contrast. I believe some of these companies will also paint them to provide color, but I've not seen any data on how well that performs over time, whether the paint is durable or not. And this looks like Washington, D.C. Cherry blossoms, I think that's the White House. So this must be Pennsylvania Avenue. I mean, look, obviously a special place in the country, a lot of architectural features, but notice how this, I guess, is granite. Notice how these contrasting colors in the granite maybe make it difficult to find the detectable warning surface. Here's the detectable warning surface at a perpendicular ramp. Here's what are called directional ramps. Many of you probably have these. Notice there's no sidewalk coming in from the left here. There's no crosswalk across this street. So this ramp just serves the corresponding ramp on the other side of the street. The key thing, the key parameter to know is what's the distance from the grade break to the back of curb. If that's less than 5 feet, put the detectable warning at the grade break. If that is more than 5 feet, then put the detectable warning radially around the back of the curb, like you see in that lower image. And here's an example of what not to do. This is actually, I'm still working from home, but when I was working at the office, this is a driveway entrance. I would use this driveway every day to the parking lot where I park my vehicle. And I have measured from the base of the grade break here to the back of the curb is 8 feet. This is not an appropriate way of handling that. There should be detectable warning material radially around that corner. because look what can happen. Imagine we have a blind pedestrian using the cane coming toward us on this walkway. And let's say they're using this curb here as their shoreline to help them navigate. But once they get here, the curb disappears and there's nothing to let them know that they're out in the roadway, in harm's way, in the traffic. So that's why it's critical to have that detectable warning wrap all the way around here. Again, keep in mind my rule of thumb. Everywhere the curb is missing at a street crossing. And here, the curb is missing, but there's no detectable warning. That's a potential safety issue. This shows the design for a parallel ramp. And as I mentioned earlier, with this design, the detectable warning surface is part of the turning space. And one set of wheels of the wheelchair may pass over those truncated domes. So that may create a rough ride, which is not desirable. But with this design, it comes with that design, I guess we'll say. It's a fact of life of that design. Here's some blended transitions. We'll start in the lower right here and go counterclockwise maybe. This one, I think we already talked about. I'm not going to say much more. This one, I have a number of concerns about. Number one, it looks too steep. Remember, a blended transition, 5% is the max grade. Also, it appears to me that this is one of those formed in place designs. So the quality control is an issue. And also it looks like they just painted it with enamel paint. And so when that's wet, that's going to be a slippery slope to navigate. How about this one in the upper left? Kind of weird, right? We have a curb. If you have a curb, you don't need detectable warnings. We use them when the curb is missing. But I think what's going to happen here, I think this agency is going to pave this street to make it flush with this street in the upper left here. And so let's assume the curb will be missing around here once they pave that. This is still not good to me. There needs to be 2 feet continuous around that corner, not these gaps or these wedge-shaped areas here. It looks like they had pieces left over from elsewhere on the job and they just tried to fit it together, but that doesn't work. And then in the lower left here, this is the detectable warning. It's like the whole length of the ramp. But the problem is the curb is missing throughout this. This is like a blended transition. The curb is missing throughout the whole corner. And again, as I said, we need to have detectable warnings everywhere the curb is missing. Here's some other examples of proper placement. I should note, I see this sometimes, maybe you all have it, kind of, what do you call that, grooving or scoring of the concrete at the top of the ramp. I think it's maybe done to help pedestrians realize that they're going to be going down a slope or a grade. This is not required by any sort of accessibility criteria. And the truth is, I mean, I think people were well intentioned, but the truth is, with a cane, one cannot detect this surface from smooth concrete, from asphalt. So well intentioned, but really the funds, if that requires extra funds in terms of finishing the concrete, those funds could probably be better used elsewhere. Median islands. The width of the path should be 5 feet minimum. If it's 6 feet or more in the direction of pedestrian travel, meaning from this side of this island to over here, if that's 6 feet or more, this is considered a pedestrian refuge island. And so as we see here, we need to use detectable warning surfaces. If it's less than 6 feet, it's considered a pass-through or a cut-through, and the surface should be smooth. If it's less than 6 feet, it's not a refuge area. We don't want pedestrians hanging out there. We want them to think they're still in the street. So if it's less than 6 feet, there should be no domes there. But I see that done incorrectly throughout my travels. This is, I would say, a correct situation. I don't know the dimension there in the direction of travel, but it certainly looks to me like it's well more than 6 feet. So this is a refuge area, and so it is appropriate and necessary to put the detectable warnings there. This is less than 6 feet. In fact, these are less than 2 feet of detectable warning surfaces. And so this is not a pedestrian refuge island. This is a pass-through or cut-through. We don't want pedestrians hanging out here, so this concrete surface in the median should be smooth. These detectable warnings should not be present. Let's see, I just wanted to mention, maybe some of you use this design, the so-called Z crossing, where pedestrian could cross from the bottom here, and then in the island, they turn to the right. The idea is as they're walking to the right here, or toward the right side of the screen, they can check for gaps and speeds, distances to oncoming vehicles, and then they turn left and cross the roadway at right angles. This has been widely used internationally for a long time. It's starting to catch on in the United States. The point I want to make is if this is, say, a concrete island here, this has to be a detectable path. It cannot just be painted on the concrete surface. It has to be a detectable path, either, say, curbing or railing on top of a curbing, something like that. Another place where we need detectable warnings is at railroad grade crossings, where the sidewalk crosses the tracks, to warn pedestrians, blind pedestrians, that they are about to cross the tracks. And notice, locate the edge of the detectable warning nearest the rail crossing, a minimum of 6 feet and 15 feet maximum from the center line of the nearest rail. And that's, as it says, that's the center line of the steel rail, not the center line of the gauge of the tracks, the center line of the steel rail. And that may very well place the detectable warning on railroad right-of-way, in which case public works crews don't have the authority to install those. So the agency, public agency, may want to write to the railroad advising them of their responsibility to install those detectable warnings. This is in my area. It's not in the city here, Morgantown, but in my area, and it's an example of detectable warnings at a rail crossing, but it's not the best example of a crossing. Notice how the crossing is not full width. There's kind of a drop off there, but at least this shows the use of the detectable warnings at a rail highway grade crossing. Here's another example. I believe they call this the Music City Trail in Nashville, Tennessee. It's a multi-use, shared use path. And here that you can see the trail crosses a railroad track, and so they have the detectable warnings across the full width of the trail. A question that comes up, maybe some of you are thinking about this question already, is what about detectable warning surfaces at driveways? Do I use them, not use them? Do I use them all the time? When do we use them? Well, here are my sort of guidelines for use at driveways. As I keep saying, I would use them where the driveway looks or acts like a street. So for example, a driveway to a single family residential home, to me, doesn't look or act like a street. So I wouldn't use detectable warnings at driveways to single family homes. You do have to evaluate each driveway separately. And these are the factors that I'd consider. I'd look at the traffic control. Certainly if there's a signal at the driveway, like you might find at a large mall or something, then I would say, yes, we definitely need to have detectable warnings. If it's stop controlled, maybe not. If there's no control, again, then maybe or maybe not. Look at sight distance. Can drivers see pedestrians? Look at traffic volume, not only the average daily traffic, but peak hour volumes. And look at the curb radius. What speed can drivers enter or leave the driveway? And if they can do it at relatively high speed, I probably would put in detectable warnings. So we're running out of time. This is my last example. This is Morgantown. This is one of our arterial roadways. And out of the view here is a popular gas convenience store that generates a fair amount of traffic. This is the main driveway connecting to the arterial. Notice it's a fairly big radius here, so traffic can travel at high speed. Notice there is a center island here, not exactly the most visible, but there is a center island. There is a stop sign. And I wasn't involved in this project. I just use this as an example. But notice they did put in detectable warnings. There's some issues with the ramps, but we don't have time to talk about those. We'll focus on the detectable warnings. So I think that's appropriate for a driveway like this. But now this convenience store takes up a whole city block, so they have multiple driveways. We were just looking at this driveway. This is a driveway on an adjacent side street. Notice it's one way out. It probably has lower traffic volume. I think there might be a stop sign there. I'm not sure. But notice it's narrower. The turning radius is tighter. And notice they did not choose to put detectable warning surfaces there. And if this was my project, I would have done the same thing. I mean, I agree with them on that. This is, believe it or not, this is actually a 2-story convenience store. So this is the upper level. This is kind of behind the store. The lot parks about 12 cars. It is a fairly wide driveway. It does have a stop sign, but notice they did not use detectable warnings. And personally, I would agree with them. This is not a busy lot. I think it usually handles employees who park there and who just go in and out at the beginning and end of their shift. So my point here is, notice this is the same land use, it's the same convenience store, but each driveway is different and needs to be handled differently from a perspective of detectable warning. And then my last slide, and this is my view, you all may disagree with me, but I think this is overuse of detectable warning surfaces. This is a popular hot dog shop in town. They just have one table inside, I think, and you can see in the summer a couple tables out here. They have a wide driveway. They're open from, I think, 10:30 to 3, 5 days a week. And in this case, detectable warnings were placed on both driveways. Personally, I think that's a little overkill. I think if this was my project, I would probably leave the detectable warnings out, but I'd document why, because sight distance is good. The facility is only open during the middle of the day and so forth. But I think we're out of time. I'll be glad to answer any questions, or if you have questions, we can talk about those at the start of class on Thursday. So thanks, everybody. Have a good
Ron.
day or so, and I'll turn it back to you, Mike.
Yeah, Ron, we do have 3 questions, and since it'll be a few days since the next webinar, maybe we can take a few minutes. For those who can stay with us, please feel free. First question from Sammy: are there any best practices for color contrast to accommodate those that are colorblind?
Oh, good question. I would just say from my experience and talking with folks is that probably the best, and I don't know, this is maybe more than color blindness, but this relates to, deterioration as we age and so forth. Probably the best color to use sort of overall would be yellow. And I know designers don't like it when I say that, but I think all things considered, probably yellow would be the best color to use. And also that sort of recognizing, what do they call it, international safety yellow or those kind of terms. So that would be my advice.
Okay, next question: how should detectable warnings be placed where we have gated rail crossings?
Good question. They should be placed just outside the gates, where you have pedestrian gates, I should say, just outside the pedestrian gates. If you don't have pedestrian gates, if it's just across the roadway, I would say follow the guidance that was on that particular slide, between 6 and 15 feet, but probably outside the gates would probably be the best advice.
All right, third question: if the flare retains landscape, can it exceed 10%?
That's a good question too. That's one of those gray areas. I mean, it probably could. I guess personally, I'd be reluctant to do that just from a safety standpoint. And even though it is retaining just material, that if there's a chance that somebody could beyond that, particularly say when it's wet or when it's snow or ice covered. There is the possibility for a slip and fall sort of thing. But that, I mean, I'm sure if you probably talk to other engineers, you might get the exact opposite answer. But as somebody who deals with safety and pedestrian safety, I would probably recommend against going more than 10%.
Well, thank you, Ron. The final comment here is looking forward to the next webinar. Thanks, Ron, from James. And thanks, everybody, for participating. We'll see you on Thursday for part 4. Thanks.
Thanks, everyone.